Buongiorno tutti, sono Rafael Nadal. Buongiorno tutti. Allora, il mio nome è Antonio Sanchez, lavoro per Juniper Networks da molti anni. Adesso lavoro nel gruppo di Contrail. Contrail è la soluzione SDN di Juniper. Allora, come la mia presentazione è peggio che il mio italiano, comincio con uno scherzo. In that way, I am sure that you will remember the presentation. So the question is, what existed before the SDN era? So here, I don't know if you have seen, there is a museum of networking history. And before the SDN era, there was Massimo. Thanks to Massimo, internet exists today in everywhere, especially in Italy. And so before the SDN era, if you look very carefully, before SDN, there was ISDN, the initial SDN era. So that was the scherzo. Nobody laughed, thank you. You can go back. Thank you, Marco. Okay, so one of the things that have changed a lot in the industry, I mean, every time we speak about SDN, we typically think about connectivity. How can I connect virtual workloads and physical workloads inside my data center? How can I connect my private cloud to the workloads in the public cloud? How can I do it multi-tenant? And everybody thinks about connectivity. Connectivity is becoming a given now with overlays and there is one point of SDN that is very often forgotten. It's security. So SDN is bringing tools to deal with the evolution of network security. So these are screenshots from a book that is Zero Trust Networks. I didn't formally ask for permission, but I guess that by doing some kind of marketing to the book, the authors won't sue me. So in the past, the most important thing for security was the concept of zone. So in an enterprise typically was placing in the DMZ, the demilitarized zone, email servers or web proxies that were had to be exposed to the internet and also to the intranet. But nowadays it's clear that this security approach, and also a very common approach, is to have a VPN. So basically all the mobile users that want to connect to an intranet just peer with an SDN gateway, with a VPN gateway, an IPsec gateway or a SSL VPN gateway that is providing access to the intranet. But once you are in the intranet, the world is yours. I mean, you can do anything, right? So there is no this zone-based security has inherently the flow that the only thing that the security infrastructure is looking at is where you are. If you got there, then you can do everything you want. Of course, there are some more advanced firewalling features, but that's basically the paradigm that is changing in the sense that today we don't really trust anyone. No matter if you are in this building, you can harm my business, right? So even though you are in my company, even though you are in probably working for my company, I still need to enforce some kind of security on you, and it doesn't depend on when you are or on where you are. This is a challenge that also needs to be solved in very simple terms. So today I'm sleeping in an Airbnb, which is a loft that is very similar to this space. So imagine there is a bedroom, you open a door and there is a bedroom and a bathroom. So that's basically what I'm sleeping today. And I found some rules that I really liked. So the Airbnb has two rules. No smoking, no noise. If you want a sophisticated security approach to be efficient, it also has to be simple for whoever defines the rules. So what's the role of Contrail in the context of security? We want to interconnect an extremely heterogeneous set of workloads. So it can be a remote branch office. If I start from the left, it can be a remote branch office with terminals connected to or servers connected to a CPE. Or it can be workloads running in a data center as bare metal servers or as virtual machines or as Linux containers. It can be workloads running on telco points of presence, for example, virtual network functions or physical network functions that are enhancing the product offering of the service provider. It can be workloads that are running on public clouds. So all this complexity, Contrail is taking care of it and is providing an abstraction on which to apply security. This abstraction is very simple. If you come from the network world, this abstraction is called port. So no matter if the workload is connected through a container virtual interface, or through a virtual machine interface, or through a bare metal server physical interface or VLAN, doesn't matter whether the workload is running on your private cloud or on your public cloud, the point of connection of the workload to the network is called a port. And a port can be of many different natures, but it has a common set of properties. So what does a port have? A port typically has an IP address, right? And typically it belongs to when we're talking about SDN, it belongs to a virtual network. A virtual network provides first level of segmentation, whereby two workloads can typically talk to each other if they are in the same virtual network, but not if they are not in different virtual networks. That's the default. But that's, if you think about it, that's the zone-based approach, right? So it's like the first level of security. And virtual networks are typically aggregated in projects. If you are used to OpenStack, OpenStack has this project or tenant concept. So Contrail has exactly the same concept, to the point that in the integration with OpenStack, an OpenStack project gets automatically discovered by Contrail. And this is how we are grouping virtual networks together. And the very key thing is, if you are thinking of modern day security, think of the biometric passport, for example. If I go to a passport recognition office, to the police, and I show my passport, or with the machine that checks all the biometrics, etc., the guy is going to check things like the color of the passport or the nationality. But there's also this biometric. This biometric is basically a series of attributes of my face or my look that are that need to match. They need to match in the passport and in the physical guy who's showing the passport. So in that sense, in Contrail security, which is a new extension of Contrail that we are releasing in Contrail 4.1 that is released later this year, we are using the concept of tags. Tags are attributes of an object. This hierarchical structure, whereby a port belongs to a virtual network and a virtual network belongs to a project, also brings some inheritance, in the sense that the attributes of a port is the combination of the attributes of the project to which it belongs, the attributes of the virtual network, and the attributes that are assigned to the port itself. So you go from the less specific to the most specific. For example, in the demo that we are going to run today, the properties, the application will, as a tag, will be a property of the project. right? On the virtual network, in this particular demo, we're not going to assign any particular tag, but we could. And on the ports, we will assign some specific attributes like deployment, site, or tier. So what is the goal? What do we want to achieve? So we're saying that we want to do security simpler and security spanning very heterogeneous workloads. So think about this scenario. We want to achieve a security policy that performs all of the following. So here we are supposing that this project is for an application that is whatever. It can be a credit card application or a human resource application, a billing application, content application, anything. Everything you see there is an application, right? It's a project that is an application, and it's basically the life of this application takes place in two sites: the US and India. US on the left, India on the right. Also, the life cycle of the application has several phases. So there is the development phase, the test phase, and the production. So you see from top to bottom, you have the dev, the test, and the production. We call these deployments. So we have 3 deployments, 2 sites. Inside a given deployment and a given site, we can have an instance of the application, an incarnation of the application. In this case, it's a 3-tier application. It's a very common architecture where you have the web frontend, an application engine in the middle, and a database. And you have an incarnation of that in every, in some of the site colon deployment that are in this project, right? But we want to allow the communication only between the web tier and the app tier, and between the app tier and the DB tier, but we don't want to allow communication between the web tier and the database tier. We only want to allow communication between web tier and app tier inside the same site and inside the same deployment. So, for example, inter deployment is forbidden, and inter-site, even for the same deployment, production is forbidden too. So it's very common. But we are going to do it in a very easy way. This is the policy. This is the policy that we need to apply. It's very simple. So we are saying we allow traffic from web tier to app tier. We allow traffic from the app tier to the database tier, and the deployment and site must match. This match things is the secret sauce. Is what makes things simpler. Because without the match statement, we would have to create one policy for every single deployment and every single site. We would see from site development, from site US, deployment dev, then blah blah. From site US, deployment production, etc. We would have to create at least 4 policies here. And if you have more projects using the same architecture, we would need to create one policy and a high number of policies for each of them. So this match is basically what allows us to. So if we go to let me go to the problem statement. So in previous releases of Contrail and of any SDN controller, we basically have to create a policy per site or per deployment. If we want to achieve this kind of security, where we enforce security within the site and deployment, and we don't want we want to restrict some inter deployment communication. And with the new paradigm, we are having a single policy that is applied to all of them. That is applied to the whole application. So we reduce the complexity, so having less number of policies, and also the manageability is better. If we want to do a change on the policy, we only need to change in one place. We don't need to change in 10 places, the correlated places, right? And the scalability, of course, is higher. So the idea is define once, deploy everywhere. Deploy everywhere means it really doesn't matter whether the the 3-tier incarnation is running on a private cloud with OpenStack, or in a public cloud with Amazon Web Service, or with Kubernetes, Mesos, whatever, right? You just define the policy once, you apply it. So let me go back 1 second. So as I said, here are basically what we are going to do is we are going to tag the ports. Every web, when you see this web or this app thing or this DB thing, you can view this as a virtual machine or as a container. In previous networking models, you would have the app having 2 network interfaces. Could be VLANs, but it could have one to the web and one to the database, right? Because the way we were enforcing security was based by zones or by VLANs. In this case, the app engine only needs to have one interface, because this evolved security mechanism doesn't require you to have one interface per zone, because everything is taken care of by the tagging. So in this case, we have 3 deployments. We have one application, my application. We have 3 tiers. And we are tagging. So let's see how it looks like in Contrail. So now we are going to see the demo. Okay. So remember the tags. So here are the tags that are created. So application, deployment, etc. And you can see here that I can create a new tag at any time of type application, tier, deployment site, which are very meaningful keys for a developer or for an application administrator, and also a label. We can do a free form tag. So how are we attaching the tags? As I explained, we are doing it in a hierarchical manner. So first on the project, each project has some tags. So we have the dev project, which is a deployment, which has deployment dev, application, my application, deployment dev. We have the test project, OpenStack project. Application is my application, deployment is test. We have the prod project. So the ports, so after the project we have the network, the virtual network. And for every project we have a subnet. The IP address becomes a second-class citizen in SDN. We don't really care about the IP address. It doesn't mean anything. It's just something that you need in order to have connectivity, but you don't really pay much attention to it. So every project, development, test, and prod has one subnet, and we are not applying any tags to the virtual networks. We are attaching further tags to the ports. So if you see the ports for each project, if we go to the test project, a test only happens in India, right? And the tier is web, app, and DB depending on the port, right? So we have these 3 VMs that all of them are in India, and they have 3 different tiers because they are basically an incarnation of the application. So this is how we are tagging. We will go back to tags. We can see the tags that are, so where they are applied, to which ports they are applied, but we don't really care about IP addresses. We have DNS in an SDN solution. So here, first thing I'm going to do, here we have 2 hypervisors that are in the US. So we go back to OpenStack. You can see there are 2 availability zones. One is in India, and one is in the US. You see these host names? Well, these are exactly the host names where I'm going to do the demo. Have to move this here. Yeah. Okay, so these are the 2 hypervisors. I'm really sorry, but I need to look at that. Okay, so I'm going to connect to one VM. I would like mirror. I lost the mirror thing. So Mary, I have to do it here. Mirror. There you go. Okay. Sorry. Now it's good. So if I do hostname here, it says Web Production US. Web Production US. If you remember, Web Production US. US. Well, it's going to be here, production and web, okay? Again, it's not mirroring, man. As soon as I go to the PowerPoint, anyway. Okay, so from web prod US, I can ping database prod US. And it's working. I'm pinging from the web server to the database. I don't want that to happen. The web tier should only be able to ping the application tier, not the database tier. So I'm going to create a policy that is going to basically allow these two, but prevent these two from occurring, okay? So this is how I do it in Contrail. Sorry, mirroring is breaking every time I go from one to another, so here we go. Security. So I have some service groups here. I'm basically specifying the kind of traffic that is allowed from a web to an application tier, from an app to DB. So ICMP is allowed on everyone, right? And then I'm going to define a policy. The policy is going to be very simple. The policy name is Forza Italia. And I do the same in every country, but I mean it. So web to app, from tier web to, so this is stateful firewalling, to tier app pass, and also for the service up to DB, this kind of traffic, I'm going to allow it from tier app to tier DB. There is an implicit deny, which means that whatever I don't explicitly allow is going to be dropped. Okay, so as you see, the ping is working right now. But as soon as I apply the policy, the ping... Oh, no, I didn't apply the policy. I just defined it, but now I need to really apply it. So I'm going to apply it to the application. Forza Milano. No. Forza Juve. Application, and to this application I'm going to apply the policy Forza Italia. And now the ping stops. Okay? So, however, I am in prod. Remember, I am in prod web prod US, and now I can ping the app in prod in India, and that shouldn't happen, right? It's working, shouldn't work. How can I change that? I go back to the definition of the firewall policy, to the term from web to app, and I say that the site must match. But look, I am here. I'm going to see match tags. The site must match, but I am not saying that the name of the site. Just say it has to match, and that's how I economize. I do the economy on number of policies. And now, as you can see, it is not working anymore. I can do the same for deployment. And finally, last thing I'm going to show is this. I can go to monitor here, networking, and traffic groups, and the time is over. Okay, but I just wanted to show you the all projects. Okay. So you can see the traffic between its combination of application tier and deployment, and how what flows are existing, and you can click on them and see the traffic that there is, etc. So this is basically, if you want to monitor an application and see what is going on, you can do it with just one click. And you can filter. You can in 5.0 we will be able to apply artificial intelligence and do apply policies in a more sophisticated manner. So thank you very much, and sorry for the delay.